In this video, we will learn to solve 10 numericals. The book is Concepts of Physics. The chapter is Electric Field and Potential, and the writer is Shree H C Verma. The questions will be from number 11 to 20. Question number 1 to 10 we have already done in the previous video. You can get the link in description. In this question, there is a gold nucleus. The radius is given 6.9 Fermi. We have to calculate the force between two protons which are separated at largest separation. Next part of the question is asking, why do these protons not fly apart under this repulsion? So we know that the nuclear force holding them together is much stronger than electrostatic force of repulsion between two protons. Now, if we take this as the gold nucleus, the radius is 6.9 Fermi, diameter will be double of the radius, and that will be 2r, that is 13.8 Fermi. Protons are carrying a charge of magnitude 1.6 into 10 to minus 19 coulomb. Applying Coulomb's law, we can easily calculate the force between two protons when they are separated at a distance of 13.8 Fermi. We will put the standard values given in the question, and then the force will be 1.2 Newton, repulsive in nature. Question number 12 is saying that two insulating small spheres are rubbed against each other, and again they are kept at a separation of 1 centimeter. We know that if they are rubbed, charge on both will be equal in magnitude but opposite in nature, because the number of electrons which are coming out from one will be gained by the other one. So A, if suppose having positive charge, same amount of charge would be appearing on B but negative. Now force between these two is given 0.1 Newton. We have to calculate how many electrons are transferred from one to another. Let us first calculate what is the charge appearing upon them. So let us consider that the charge appearing on A is Q, positive, on B it is negative. Force will be 1 by 4 pi epsilon naught Q square upon R square. If we calculate Q square, it is 4 pi epsilon naught R square into F. So 4 pi epsilon naught value will be 1 by 9 into 10 raised to 9. R is 10 raised to minus 1 and force is 0.1. After simplifying this value, we will be able to get the Q square as 1 by 9 into 10 raised to minus 12, and Q is plus minus 1 by 3 into 10 raised to minus 6 coulomb, or 3.3 into 10 raised to minus 7 coulomb. After taking this value of charge, we can apply quantization. We know that Q is equal to plus minus NE, and take Q as 3.3 into 10 raised to minus 7 coulomb is equal to plus minus NE. N will be equal to 2.06 into 10 raised to 12 electrons. So these many electrons are transferred from A to B. That is why A is going to have positive charge, B is going to have same amount of negative charge. Now in this question, it is said that one electron is going to come out from sodium and it is being gained by the chlorine, and the distance is given as 2.75 into 10 raised to minus 8 centimeter. We have to find the force of attraction. We know that removal of electron from sodium will change sodium as positive charged particle, and gaining of electron or addition of electron to chlorine will change chlorine as negatively charged particle. And the amount of charge which is going to come upon them, the Q is plus 1.6 into 10 raised to minus 19 coulomb on sodium, minus 1.6 into 10 raised to minus 19 coulomb on chlorine. The distance is given 2.75 into 10 raised to minus 8 centimeter. If we change into SI unit, it will be 10 raised to minus 10 meter. Now to calculate the force, we have again the same formula, 1 by 4 pi epsilon naught Q on sodium, Q on chlorine upon distance square. 9 into 10 raised to 9. Charge on both same but opposite in nature, so 1.6 into 10 raised to minus 19 whole square and the distance square. On simplifying, we will be able to get the amount of force as 3.04 into 10 raised to minus 9 Newton attractive. Now question number 14 is saying find the ratio of electric and gravitational force between two protons. When we talk about proton, it is having charge as well as mass. Charge is 1.6 into 10 raised to minus 19 coulomb positive. Mass is 1.67 into 10 raised to minus 27 kg. We can consider that two protons are separated by a distance r. Then, because of their mass, force will be gravitational attraction. And because of their charge, force will be electrostatic repulsion. So we will be having the formula of gravitational force between two protons because of their mass and force of repulsion between two protons because of their charge. We must know the value of universal gravitational constant and the constant, that is 1 by 4 pi epsilon naught. So gravitational force or gravitational force of attraction between them will be gm1 m2 upon r square, or because masses are same, so it will be gm square upon r square. Then electrostatic force will be kq square upon r square. If we take the ratio, r square will get cancelled and it will be kq square upon gm square. Now put the standard values from this hints, that is g is equal to 6.67 into 10 raised to minus 11 and k is equal to 9 into 10 raised to 9. After calculation, simplification, we will be able to get the value as 1.24 into 10 raised to 36. This is the required ratio. In this question, there is a formula given, F is equal to C e to the power minus kr upon r square, and we are asked to write the dimensional formula and appropriate SI unit of C and K. See, in this particular formula, this minus kr is the power and it is nothing but just a number, pure number. It will be dimensionless. It means the dimensional formula of F is equal to the dimensional formula of C upon R square. If we compare these two, we can write the dimensional formula of C is nothing but force into R square. Force dimensional formula is mlt minus 2. L dimensional formula of distance is L, so it will be L square. Total dimensional formula is ml3t minus 2. SI unit will be Newton meter square. Now dimensional formula of K we have to calculate and its SI unit. So the multiplication of K and R, it is nothing but just a number, so it will be dimensionless. It means K is equal to 1 by R or dimensionless by R, and then dimension formula of K will be L minus 1. SI unit will be meter to the power minus 1. In the next part of the question, that is B, it is asked that take K is equal to 1 Fermi and the repulsive force between the protons is just balanced by the attractive nuclear force when the separation is 5 Fermi. Then find the value of C. So we are going to solve this part B as electric force at 1 Fermi, nuclear force at 5 Fermi. So F is equal to, that is the electrostatic force of repulsion between two protons, 1 by 4 pi epsilon naught q square upon r square is being equal to C e to the power minus kr upon r square. Here we have to compare this, r square will get cancelled, and then C is equal to 1 by 4 pi epsilon naught q square upon e to the power minus kr. Put all the values, that is 9 into 10 raised to 9 for 1 by 4 pi epsilon naught. Q is 1.6 into 10 raised to minus 19 coulomb whole square, and e to the power minus 1 Fermi into 5 Fermi. On solving, we will be able to get the value of C as 3.4 into 10 raised to minus 26 Newton meter square. Question number 16 is related to superposition principle of force. That is, when two forces or more forces are acting on a particular particle, the net force will be vector sum of two or more forces. So in this question it is saying three equal charges are present at the three vertices or corners of an equilateral triangle. When we are talking about equilateral triangle, the angle will be 60 degree each. These are the three charges, positive in nature, amount is 2 into 10 raised to minus 6 coulomb. Side of this particular equilateral triangle is 5 centimeter. Force between these two charges will be repulsive in nature along the line joining. Let us take this as F. Then force between another pairs of charges will be same F, and along the line joining the charges direction you can see here. If we talk about the net force, will be given by the vector sum of these two individual forces. We are going to calculate what is the value of F, that is force between any two charged particle. By applying Coulomb's law, we can take the value 9 into 10 raised to 9, charge 2 into 10 raised to minus 6, distance 5 into 10 raised to minus 2 whole square, and then we can calculate it as 14.4 Newton. Net force will be equal to vector sum, that is F square plus 2FF cos 60 degree, because the direction between, or the angle between these two forces F and F is 60 degree, and it will be coming as root 3 F. F value will be taking 14.4 Newton into 1.732, it will be coming as 25 Newton. Obviously it will be perpendicular to the base of the triangle. Question number 17 is also same principle of superposition principle of forces. Here it is given four charges present at the corners of a square. Side is again 5 centimeter. Let us take this diagram. Four charges, 5 centimeter. But here the force will be between two pairs which are present side by. It is F and F. Resultant of these two will be F dash at 45 degree with each. The force between two charges which are present at diagonally opposite corners, it will be F double dash. And now total force will be sum of F dash plus F double dash. So from previous question we can take the value of F, because the distance was 5 centimeter, charges were 2 into 10 raised to minus 6 coulomb, 14.4 Newton, and then F dash will be equal to under root F square plus F square 2FF cos 90 degree, so it will be root 2F. And then F double dash is nothing but force between two charges which are present at a distance of root 2 into side, that is root 2 into 5 centimeter. So root 2 into R we are going to have, and after calculation we will be able to get 1 by 2 1 by 4 pi epsilon naught q square upon r square, and this is nothing but F, and F value already we are having. So net force will be F dash plus F dash, F dash plus F double dash, and then it will be root 2F plus F by 2, F common root 2 plus 1 by 2. F value we are going to have 14.4 root 2 plus 1 by 2, and after taking the value of root 2, that is 1.414, and 1 by 2 0.5, if we multiply the answer will be 27.56 Newton, and direction you can see it is diagonally outward. Question number 18 is saying that this one hydrogen atom contains one proton and one electron, and we know the first orbit, the radius is having 0.53 angstrom, and when charge is present into the first orbit it is said to be in ground state. The question is, find the magnitude of electric force between the proton and the neutron and the electron of a hydrogen atom in its ground state. Let us take Charge on both will be same, that is 1.6 into 10 raised to minus 19 coulomb. Distance is 0.53 angstrom or 5.3 into 10 raised to minus 11 meter. Formula again same, 1 by 4 pi epsilon naught q1 q2 upon r square. Put the value, simplify it, and then we will be able to get the answer as 8.2 into 10 raised to minus 8 Newton, obviously repulsive in nature, sorry, attractive in nature. This force of attraction is going to help into the next question. In the question number 19, it is said, find the speed of the electron in the ground state. In this question, question number 20, this x-axis and charges are present at every 10 centimeter, 10, 20, 30, 40 and so on till 100 centimeter. And the amount of charge, first charge is present, which is at 20, which is at 10 centimeter, is 1 into 10 raised to minus 8, then 8 into 10 raised to minus 8, then 27 into 10 raised to minus 8. If you see the pattern, it is nothing but 2q, 3q, 4q, 5q, 6q, and at last it is 10q, that is 1000. We have to calculate the force on a charged particle having 1 coulomb present at origin. Again, we can apply the superposition principle, or we can simply add, because all the forces are going to be in the same direction, that is negative x-axis. So we are applying the formula F is equal to 1 by 4 pi epsilon naught q1 q2 upon r square. Q1 is 1 coulomb, q2 every time we have to take the different value. So 1 by 4 pi epsilon naught we will be taking common. Q1 1 coulomb will be taking common. First it will be q2 as 1 into 10 raised to minus 8 or 1 to the power 3 into 10 raised to minus 8 upon distance square, that is 10 centimeter is 10 raised to minus 1 meter, and square it will be 10 raised to minus 2. Similarly, next will be 2 to the power 3 upon 4 into 10 raised to minus 2. Third and the last one, 10 raised to 3 into 10 raised to minus 8 upon 100 into 10 raised to minus 2. On simplifying, we can see that 10 raised to minus 8 will be common, and from the denominators 10 raised to minus 2 will be common. Then 1 cube, 2 cube, 3 cube upon 1, 4, 9. If we take 1, we can write 1 square. If we take 4, we can take 2 square. 9, 3 square. So after comparing this, we can take 1, here 2, here 3, here 4, 5 up to 10. It will be simple algebraic sum of 1 to 10. We know that if we are going to add 1 to 10, it is nothing but 55. So 55 into 10 raised to 3 into 9, we are going to get the value as 4.95 into 10 raised to 5 Newton. That will be the total force of repulsion on charge q is equal to 1 coulomb present at the origin along negative